This is tutorial number 2 of DSP. So we have completed first tutorial, and some of the knowledge that you have gained from there will be helpful in tutorial number 2 as well. So the first question is determining the Z transform of following signals. Right. So you were given the signal xn, right? So as an example, the first one. So A xn is equal to 3000614, and you can see 6 is bolded. So bold means that is the value at n equals 0. So when n equals 0, xn is equal to 6. Okay. So likewise in next one, xn is equal to 0, 1, 2, 3, 4. 4 is the value at n equal 0. Okay. Then next one, xn equals 0.5 to the power n into un. Then un xn d xn is equal to un minus u n minus 4. So we'll see how to determine the Z transform of the following signals. Right. So first of all, we'll take a look at A. So in here, okay. So I will explain line by line. So starting from first one, xz is equal to, so that is a definition of Z transform, right? Sigma n equal minus infinity to plus infinity xn into z to the power minus n, right? But in our case, right, so as I have told you, 6 is the value at n equals 0. Therefore, if you are going from 6 to the left hand side, next you have a 0 value. That 0 is the value at n equal minus 1. The next 0, when you are keep going to the left hand side, that is the value at n equal minus 2. Then the last 0, that will be the value at n equal minus 3, right? Then 3, that is the value at n equal minus 4. Okay, so let's go back to 6, xn value 6, right? So since that is the value at n equal 0, 1 is the value at n equal 1, right? 4 is the value at n equal 2. So therefore, for our case, our n value is having the range from minus 4 to 2, right? Minus 4 to plus 2 only, because we have altogether 7 values: 3, 0, 0, 0, 6, 1, 4. Okay, so therefore I have reduced our equation to n equal minus 4 to 2, xn is to the power minus n. Okay, then I'll substitute n equal minus 4 to plus 2 to the equation, so you can see how it goes. So x minus 4 is to the power 4 plus x minus 3 is to the power 3, because when n is equal to minus 4, z to the power minus n is z to the power 4, right? So likewise, then I have expanded it up to n equal 2, right? So therefore in the given expression of xn, I know the values of x minus 4, x minus 3, x minus 2, x minus 1, x0, x1, x2, right? So what we have to do is just substitute those values from there, right? So after I have substituted, so it will become 3 z to the power 4 plus 0 into z to the power 3 plus 0 into z squared. Likewise it goes, right? Then after we simplify that thing, right, what we are getting is 3 into z to the power 4 plus 6 plus z to the power minus 1 plus 4 z to the power minus 2, right? So again, you have to remember, I have told you that when we are finding the Z transform, it is not only about finding the transform, right? Finding the transformed function but the region of convergence, right? So if we take a look at xn, right, xn, right, so xn, it has values from it has values for n equals 0 and for n negative values, that means it has left hand values, and for n positive values, that means right hand values, right? So as we have learned from theory, in here this is two-sided sequence, right? Two-sided sequence. So two-sided sequence means it will consist of both n negative and positive values, right? Therefore, the region of convergence for this is, right, entire z plane except z equals 0 and z equal infinity, right? So you can see why that ROC is like that, because let's say if you substitute z equals 0, what will happen to the terms z to the power minus 1 and z to the power minus 2 in xz? They will become infinite, okay? Infinite, that means it will not converge. Xz is a series, so that series will not converge. So therefore z transform is not defined when xz does not converge, okay? And let's say substitute z equal infinity, so then what will happen to the terms which contains z squared, z to the power 4 in xz? That will become infinite. So that means entire xz will become infinite. So therefore again it will not converge. Therefore we cannot define z transform in when z equal infinity as well. Therefore the only values that will not include in the region of convergence are z equal 0 and z equal infinity. All the other values of z will include in the region of convergence, right? So this is the next example. Xn equals 0, 1, 2, 3, 4, right? So 4 is the value at n equal 0. Again, as we have done previously, I have written the Z transform equation. So that will be given like this. So then again, I know I have values only for x minus 4, x minus 3, x minus 2, x minus 1 and x0. So therefore I will substitute only those values for n. Then I am getting x minus 4 z to the power 4 plus x minus 3 z to the power 3, likewise, right? So then after I have substituted these things, the x minus 4, x minus 3, x minus 2, x minus 1, x0, that means the values of x when n equal minus 4, minus 3, minus 2, minus 1, 0. This is what you are getting. Z to the power 3 plus 2z squared plus 3z plus 4, right? So again we have to consider the region of convergence, okay? So if we consider this thing, right, this is entirely left-sided sequence. Left-sided sequence means it will only have values when n is equal to 0 and for n is negative. There are no n positive values, right? If you draw this thing in a graph, you will see the entire uh, graph will be uh, left sided. So therefore again for this one, ROC is the entire z plane but except z equal infinity, because when z equal infinity the series will not converge. So therefore we have to consider ROC as the entire z plane except z equal infinity. Then the next question, right? Written again I have written definition. Then I have substituted xn equals 0.5 to the power n un, right? Function multiplied by, so in here it has become like 0.5 to the power n is multiplied by un. So if any function is multiplied by un, that means it will only have values for n equals 0 and n is larger than 0. There won't be any values for n is less than 0, right? So by taking that into account, I have written sigma n equals 0 to infinity 0.5 to the power n is to the power. Okay, so then I have simplified that one as 0.5 into z to the power minus 1 and the whole thing to the power n, right? I have written that one because we know that sigma n equals 0 to infinity a to the power n is equal to 1 over 1 minus a if magnitude of a is less than 1, right? So if we compare our equation with instead of a, what we have in here is 0.5 into z to the power minus 1, right? So as I have explained you previously, right? Magnitude of z, right? Magnitude of z is equal to 1, right? Magnitude of z is equal to magnitude of z is equal to r, right? Magnitude of z is equal to r. So therefore, if magnitude of z into 0.5 is less than 1, we can find a z transformation, right? So therefore, for magnitude of 0.5 into z to the power minus 1, right? Z to the power minus 1 less than 1, right? We can write this is equal to 1 over 1 minus 0.5 into z to the power minus 1, right? Uh, so therefore, what we are getting in here is uh, magnitude of z larger than 0.5, right? Then the z transform will be 1 over 1 minus 0.5 z to the power minus. Okay. So this is the next question, right? Uh, some of the students has asked me to explain that and uh, feedback diagram again. So what I think is if you refer this thing, um, you will correctly understand what that feedback and everything, right? Because everything will be same when it comes to block diagrams, right? So first we'll read it. So first read the question for the discrete time system whose block diagram is shown below. So block diagram is shown below, and you are asked to find an expression for yn, then hz and hn, right? So impulse response means hn, that means the inverse is a transform of hz, right? So this is what we have given, right? So we'll see how can we find an expression for yn, and from that one hz and then h, right? So uh, first we'll refer, right? So first we'll refer the time domain. Time domain means xn, yn, those kind of terms, right? So in here, uh, so you can see that we'll start from the beginning. We have xn, right? So xn, then it is given into z to the power minus 1 block, right? So if you can remember, what will happen if xn goes through z to the power minus 1 block is xn will become xn minus 1. So it is shown in there, it will become xn minus 1, right? So then we go through the same line horizontally to your right hand side, then again that one will go through again z to the power minus 1 block. So therefore what will result is x n minus 2, because xn minus 1 minus 1 xn minus 2, right? So when it is multiplied by 0.5, it will become 0.5 into x n minus 2, right? So that is 1. Then again go to xn, right? So xn will go in another branch, right? So therefore in that branch also, in vertical you can see it will be xn, right? So xn, then when xn multiplied by 0.5, it will become 0.5 xn, right? Okay, so that will add to that again. It will go to that summation block. That sigma means that is the summation block, right? Then refer xn minus 1, right? When xn is multiplied by z to the power minus 1, we are getting xn minus 1, right? So in there, xn minus 1, when it goes to 1 is, and previously 0.5 and 0.5, they are the amplification. So what we are doing is we will just multiply the value, right? So when xn minus 1 is given in amplification block of 1, what we are getting is 1 into xn minus 1, right? So again that will add. Okay, then what you can do is you can convert all this xn minus 1, xn minus 2, and every term into z domain, right? So how can we convert it into z domain, right? Here xn will be xz, right? Then xn minus 1 will be z to the power minus 1 into xz, right? So if you can remember the property of shifting, time shift will result z to the power minus 1 in the z domain. So xn minus 2 will be z to the power minus 2 xz. 0.5 xn minus 2 will become 0.5 z to the power minus 2 xz, right? So then we will have here z to the power minus 1 into xz. That is for xn minus 1, right? Then 0.5 xn, that will become 0.5 xz, right? Then everything will be added into this summation block, and the result will be yn, and the transformation of yn will be yz, right? So therefore now, taking all these things together, we can find the things that we were asked to. Okay, so according to this one, there are three branches will be adding up at that summation block, right? 0.5 x n minus 2 and x n minus 1 and 0.5 xn. So therefore addition of all these things will be equal to yn, right? So after the summation block, the resultant will be yn. So yn will be the addition of these three, right? Here if you want, you can convert yn into yz, or else by taking a look at the diagram, you can write what is yz. Yz is equal to 0.5 z minus 2 xz, that is one branch to the summation block. Then 1 into z to the power minus 1 xz, that is another branch. Then 0.5 xz, that is another branch, right? That is another branch. So therefore we know that hz is yz divided by xz. So therefore if we divide yz by xz, what we are getting is 0.5 into z to the power minus 2 plus z to the power minus 1 plus 0.5. Okay, so that is part B. Then you need to find the hn. So how can you find hn? Again, use the inspection method. So what is meant by inspection method? Because here hz equals 0.5 into z to the power minus 2 plus 1 into z to the power minus 1 plus 0.5 z to the power 0. So that z to the power value, that will give us an idea about the value of n, because z to the power minus n is the term associated with xn, right? Therefore here you have z to the power minus 2. That means when n equal to, value is equal to 0.5, right? That is the first term of hz. Then z to the power minus 1, so that means when n is equal to 1, the value at n equal 1 is 1, right? The next one is z to the power 0. That when n is equal to 0, hn, or the value will be 0. So by concluding everything together, we can write hn equals 0.5 when n equals 0, 1 n equal 1, 0.5 when n equal 2. Then if we put this thing in equation, what you are getting is 0.5 delta n, that will represent value of hn when n is equal to 0. Then 1 into delta n minus 1, that will represent value of hn when n equal 1, plus 0.5 delta n minus 2, that will represent value of hn when n equal to 2. Okay. So likewise we have found yn, hz and hn. So again this is a simple task, right? So find the impulse response, right? So impulse response means that is hn, right? So you are asked to find, again in here you are asked to find hn, right? So how can you find, right? So this is same as the previous one, right? Find the hn from hz. So index of z will be minus n. So the value associated, or the value multiplied with z to the power minus n, will be the value of h when n is equal to n. So therefore we can identify that when n is equal to 0, value of hn is 2. When n is equal to 1, value of hn is 1. When n is equal to 2, value of hn is 3. When n is equal to 3, value of hn is 1. When n is equal to 4, value of hn is 2. And then we can put that thing in an equation, right? So this is the weighted uh, weighted unit sample response of unit sample representation, right? So therefore we can directly write hn 2 into delta n plus 1 into delta n minus 1 plus 3 into delta n minus 2 plus 1 into delta n minus 3 plus 2 into delta n minus 4. Okay. Then question number 4, a discrete time signal. You were given this discrete time signal, right? So 0, 2, 6, 3, 1 for n equals 0, 1, 2, 3, 4. So we can identify the 0 of hn, that is the value at n equal 0, right? Is passed through a system with the impulse response hn. So hn is given, then plot xn and hn and determine their relationship. Then part B, find the output of the system, right? So this one, right, here xn we can write 0, 2, 6, 3, 1, right? Then hn from the given value, so you were given from n equal 1, n equal 2, n equal 3, n equals 4, only those values, right? But what you can understand it, that means when n is equal to 0, value of hn is 0. Therefore we can write hn as 0, 2, 6, 12, 4. 0 is the value at n equal 0. So afterwards you are asked to draw hn and xn and hn, right? So we have done how to draw this xn and hn, right? That means drawing discrete time signal. So you can draw it, right? Then you are asked to determine what is the relationship between uh, relationship of xn and hn, right? So actually in here what you have to understand is uh, what I need you to do is you need to find what is xn and hn, right? So xn will represent the input and hn will represent the impulse response of the system. So the resultant will be yn will be the output. So if you convolve, so that means xn convolution with hn, what we are getting is yn. So yn is xn convolution hn, right? So uh, again xn and hn, these are just two discrete time signals. So therefore using the method that I have told you in the previous tutorial, what you have to do is you have to find the linear convolution between xn and hn, right? So linear convolution, right? So you have to find linear convolution between xn and hn, and then you can find what is the value of yn. So I'm not going to do this in here because I have done this in previous one, but what you have to do is you have to find the linear convolution of xn and hn, then find yn. Okay. Question number 5. So you are asked to find the inverse Z transform, right? So XZ is given like this. So if you can remember, we have learned few methods of finding inverse Z transform, right? So according to the things that we have already learned, the best method of finding Z transform for this is using the partial fraction expansion, right? So that means partial fraction expansion is not a method actually, not a method of finding inverse Z transform, but it is a supporting method, right? That means if you can make it to uh, partial fractions as we for where we have the inverse Z transforms, right? So then we can find it directly, right? uh, so partial, first of all what you have to do is find the partial fractions, right? So if you can see this x z, right, in the numerator you have maximum power of z is 1, right? But in the denominator, if you expand this, the maximum power of z is 2. So therefore the numerator cannot be divided by the denominator, right? That means if you use long division, you cannot divide. It's a plus 0.8, you cannot divide by the denominator because the maximum power of z is less of the numerator. Therefore what this will result is just two partial fractions which will have these two factors uh, at the denominator, right? But before going into making finding the partial fractions, so if you can remember from the examples that I have given you in the lecture, right, what you had was z to the power minus 1 terms. That means we need z to the power minus 1 terms because when we are finding the z inverse z transform, we have used that method, right? So therefore before finding the partial fractions of x z like this, first of all what you have to do is you have to divide both numerator and denominator by z squared. We are dividing numerator and denominator by z squared in order to make this thing with in z to the power minus 1 terms, right? So why z squared? Because the maximum power that you can see it in either numerator or denominator is z squared. 2 2, so 2 means z squared, so you have to divide both numerator and denominator by z squared. Then this z minus 0.5 will convert to 1 minus 0.5 z minus 1. Then z minus 0.2 will convert to 1 minus 0.2 z to the power minus 1. Then the numerator will convert to z minus 1 plus 0.8 z minus 2, right? So here this is what we are getting for xz when we divide by both numerator and denominator by z square. So as I have explained previously, xz is same as the previous one. So therefore this will have only two partial fractions, as I have told you. A1 divided by 1 minus 0.5 z to the power minus 1 plus a2 divided by 1 minus 0.2 z to the power minus 1, right? Then you what you have to do is still understand, still we are in the partial fraction finding process, right? So you have to find a1, so a1 and a2. So how can you find a1 and a2? A1 will be xz multiplied by 1 minus 0.5 z to the power minus 1, then substitute z equals 0.5. So this is how we have learned. So we have used this method in the previous one. So therefore we'll use it in here. So when we multiply the xz by 1 minus 0.5 z to the power minus 1, what you are getting is z to the power minus 1 plus 0.8 z to the power minus 2 divided by 1 minus 0.2 z to the power minus 1. Then when you substitute z equals 0.5, so understand this z equals 0.5 means z to the power minus 1 means 1 over 0.5, which is 2. Z to the power minus 2 means 4, right? So therefore if you simplify a1, you are getting as 26 over 3, right? Using the same method, you can find a2 xz multiplied by 1 minus 0.2 z to the power minus 1. Then substitute z equals 0.2. So z to the power minus 1 plus 0.8 z to the power minus 2 divided by 1 minus 0.5 z to the power minus 1, right? So when z is equal to 0.2, what will be z to the power minus 1? 1 divided by 0.2. 1 divided by 0.2 means 5, right? Then z to the power minus 2, that will be 25, right? So likewise, when you substitute in here, over 3, okay? Then so here you can see xz you are getting as 26 over 3 1 minus 0.5 z to the power minus 1 minus 50 over 3 by minus 0.2 z to the power minus 1, right? Then we know that for an un is a transform or inverse is a transform pair, that is 1 divided by 1 minus a z to the power minus 1, right? For region of convergence, magnitude of z larger than a, right? So therefore, using that one by comparing the given Z transform pair and using the region of convergence larger than 0.5, right? We can write xn equal 26 over 3 0.5 to the power n un minus 50 over 3 0.2 to the power n un. So here why we have used magnitude of z larger than 0.5, because if you take uh, 26 over 3 1 minus 0.5 to the power z to the power minus 1, it can be written as 0.5 to the power n un multiplied by 26 over 3 for ROC larger than 0.5. Then next term 50 over 3 1 minus 0.2 z to the power minus 1, we can write that as 50 over 3 into 0.2 to the power n un when ROC is magnitude of z larger than 0.2. So therefore, uh, when we are taking magnitude of ROC larger, magnitude of z larger than 0.5, that will satisfy both larger than 0.2 and larger than 0.5. So therefore, for that ROC we can write it. Then question number 6, find the transfer function hz of the system characterized by the following difference equation. Then plot the pole zero diagram and determine their stability, right? So again, what we have to understand is I have told you how to find, right, how to find whether the system is stable or not using the pole zero diagram, right? So before that one we need to find what is hz, right? So yn is 2xn minus xn minus 1 minus 3 yn minus 1 minus 2 yn minus 2. Then of the entire thing, if we take this transform, and what we are getting is yz is equal to 2 into xz, right, minus z to the power minus 1 xz, right? Because xn minus 1 transformed into z transform, that will be z to the power minus 1 xz, right? Then minus 3 z to the power minus 1 yz, that is the transform of 3 minus 3 yn minus 1, right? So if is a transform of xn minus 1 is z to the power minus 1 xz, is a transform of yn minus 1 is z to the power minus 1 yz, right? Then minus 2 z to the power minus 2 yz, right? That is the z transform of minus 2 yn minus 2 yn minus 2. Yn minus 2 will have is a transformation of z to the power minus 2 yz, right? So likewise, then what you have to do is you have to separate yz terms and xz terms, right? So if you separate that thing, you will get 1 plus 3z to the power minus 1 plus 2z to the power minus 2 yz equal 2 minus z to the power minus 1 into xz, right? Then you know hz is yz divided by xz. So hz you can find as 2 minus z to the power minus 1 divided by 1 plus 3 z to the power minus 1 plus 2 z to the power minus 2, right? So here this one, if you want to find the poles and zeros of this one, that would be somewhat hard. So therefore what we can do is, in order to remove that z to the power minus indexes, right, minus indexes, you can multiply both numerator and denominator by z squared, right? So if you multiply both numerator and denominator by z squared, you are getting this as z 2z minus 1 divided by z plus 2 into z plus 1, right? Like that, you are getting it like that. So therefore you can find what are the poles and zeros, right? So what is meant by pole and what is meant by zero, right? Pole means the values of z which make z infinite, right? That means if you substitute those values for to z, the um, the hz will be infinite, right? That is what we call as a pole. So what we call as a zero. Zero means the values of z which will make hz equal 0, right? So from this one you can clearly see, if you substitute z equal to z equal minus 2 and z equal minus 1, hz will be infinite. So therefore z equal minus 1 and z equal minus 2 are the poles of this, right? Then by looking at this one again, you can see if you substitute z equals 0, so refer the numerator, if you substitute z equals 0 and z equal 1 over 2, right, z equal 1 over 2, hz will be 0. So therefore our two zeros are z equal 0 and uh, z equal 0 and z equal half, right? So like that. So therefore z1 equal 0, z2 equal 1 over 2, z1 z2 means they are referred to zeros, right? Poles are p1 equal minus 2, p2 minus 1. Then if you draw a pole zero plot, so you can see in the z plane, right, in the z plane, if you draw those things, so I have marked zeros by a circle. So z1 0 equal 0, z2 equal half, they are marked as circles. Then two poles are marked by two crosses, right? So therefore at minus 1 and minus 2 I have marked the crosses, right? So again I have drawn the unit circle, right? Unit circle. So according to our stability check, right, if the poles are not inside the unit circle, right, the system is unstable, right? So here you can see, after I have drawn the unit circle in here, one pole which is minus 2, that is outside the unit circle, right? Minus 2 pole that is outside unit circle, because inside you have all zeros, and inside at the unit circle you have z1 sorry the pole minus 1. So therefore minus 2 is outside the unit circle. So therefore what we can say is system is unstable, right? So likewise if you are referring, right, if you are referring or if you are going to understand whether a system is stable or unstable, what you have to do is you have to do the draw the pole zero plot. So this plot is called the pole zero plot. Pole zero plot is drawn in the z plane, right? So we have to mark poles by a cross and zeros by a circle, as I have marked in here, right? So therefore what we can see is the system is not stable, that means the system is unstable, right? So therefore we can conclude the system, the system's property which which is an unstable system. Okay, so what you have to do in this tutorial is, so that is the end of the tutorial, right? So what you have to do in this tutorial is, you have to repeat all the examples that I have done, right? And and then you can discuss them in a discussion session that which I have created in the study net.